Hello, YouTubers. This is going to be the fourth main video, in our series about talking about, the engineering standard. If you're not familiar with this series or not familiar with the engineering standard, it's basically a collection of, interpretations of solid principles and patterns and code best practices and experiences all, combined together out of the years and years of experiences in the software industry. I'm trying to bring together for you into one single form of what I call the standard. And that standard is basically is what worked for me personally throughout my entire career, changing industries, changing, technologies. We went from WCF to, RESTful, and now the people are talking about GPRC, and still the standard withstands, and can hold up for all these technology changes because the standard is a mindset, of solving problems and, properly, componentizing and modularizing your system. So it doesn't matter really even if you're using a programming language to solve your problems or you're using this standard to break apart a problem that you're trying to solve in physics or mathematics, whatever the case may be. It just so happens that the language that I'm using to express this way of solving problems is the engineering standard as C#, as a programming language. In the previous video, we talked a little bit about abstraction, abstract components, right? So we talked a little bit about, how every system have some dependencies, of some sort, and these dependencies, may or may not be local, something that you own, and you need to abstract these dependencies with contracts, so your business logic, your core functionality is kind of protected and living within this kind of orb that, protects, or under a dome that basically protects it from all the changing technologies around it. What that basically means is that, let's go back into the blackboard here real quick and let's talk a little bit about, what that really means. What that means is that if I go in here, if I go and say, I have a system, it doesn't matter what this system is. Your system in here Your system here may have some inputs. So there's I/O, right? So there's inputs and there's outputs of that system. So here's your input and here's your output of the system. And very likely that this system at some point in time will have some sort of dependencies, right? So let's put the input output on these sides. So you have this input coming in. Let's put it this way because I really like to make my point clear. So this is the input right here. And here's your output. So the system is responding back and giving you back some sort of output out of your system. There it is. Here it is. And your output is basically mainly focusing on making sure that whatever you requested is what you're receiving from a functionality standpoint. Okay, so you're sending in a request to retrieve all students, and you're getting back an output of all the students that you requested. Or whatever the output may be unauthorized, there's an error, whatever the case may be. Okay, there's this piece in your system. But your system also may have some dependencies. So you may have a dependency out here in your system that basically says, okay, I need to pull that data from somewhere, or I need to validate, I need to check out the validation dependency. Yeah, so basically you have dependencies and side effects that happen on the side, and these dependencies is basically what helps your system actually provide a particular service. Some systems don't need any dependencies, of some sort, but these are very, very rare, and we will talk about all of these when we talk about our engineering standard. Okay. What's happening really is that these three things in your system, they change all the time, right? So technologies change. Like I said at the beginning, at some point in time, we used to have, WCF as a form of communication, and then RESTful came in. So now we're talking HTTP, REST, right? And now newer and newer technology keep emerging, to change how we do the input-output. The dependencies themselves also change, right? At some point in time, people used to use, SQL, and now they want to use NoSQL, and still, SQL is still very relevant, but technologies keep changing, and, the dependencies and all of the things around these technologies. I'm changing the type. Now imagine this, yeah, like you're going back into changing these dependencies. Here's the deal. In order for you to truly build an agnostic system that can withstand changes in these dependencies, you have to build a form of abstraction. You have to kind of put a little, protection layer around that system that you have. And that protection layer is what's going to help your system, live throughout the times, meaning that your system will not need a lot of changes, especially the business logic that's within your system. That's really all that matters, right? The business logic within the system will not need to change as long as you have that layer of protection around whatever your system is doing. Okay, if we agree on these principles, then there's a couple of things that I really need you to focus on. This layer here is what we call abstraction. I want you to remember this word because we're going to be using it a lot. Abstraction. An abstraction means that whatever these dependencies are that are around my system, they shall not at any point in time impact the internal logic of what this system is doing in any way, shape, or form. It should just impact this outside boundary of your system. All right, so we did that abstraction layer, and it only impacts the outside boundaries of your system, so your system stays exactly the same. Now let's get a little bit closer about what that means. Hassan, okay, this is a good theory, right? But what does that really mean when you put it on the ground? Okay, let's say you have an ASP.NET Core application. So you have a controller endpoint that's offering an endpoint, and you have a service in here, and you have a broker. In our terms, what I call to be dependencies is whatever, so this is a broker in here, and this is a service. In my terms, whatever I call, let's call them brokers, so we're talking about the generic, form of things. Okay. Your controllers and your brokers may change all the time. They may change all the time. And also a little teeny tiny part of your services may also change all the time. But that foundation layer that basically separates, your actual business logic from its external dependencies should not allow any leakage beyond that point into your core business logic. What does that mean? This is all great. It sounds great. But what does that really look like in the real world? Let's bring this to a realistic scenario. So let's say, for instance, you have an API endpoint in here. And this API endpoint says get all students. And get all students is hitting a processing service. So this is students processing service. And your student processing service is hitting another service that's called student service. This is a foundation service. And then you're hitting a storage broker and you're calling an API a database. Storage broker. So this is your students broker. And you're basically getting a request to retrieve all the students. This guy goes in and so on and so forth. It just goes through the system like this. Now, when we say a service, we basically mean anything that can be processing, foundation, orchestration, coordination, aggregation services, and management services. There's so many different types. When people talk about single responsibility, when they talk about separation of concern, this is just a principle. But when you try to interpret that into something that's actually useful in reality, there is much more to building business logic than just saying the student service should handle student service and the teacher service should handle the teacher service. There is categorical separation of concern, where particular service applies a certain category of business logic, because business logic could be many things. It could be mapping, it could be aggregation, it could be orchestration. You're calling multiple services on multiple resources to orchestrate some work, right? You can't just stop. Like a lot of people would stop at the point where they say, oh, single responsibility, meaning every service need to do one thing and one thing only. So the students are students, teachers, and library cards, library cards. That's half of the picture. There's a bigger part out there where we go and say, there's foundation services that do basic validations, and then there's processing services that do higher order business logic, and then there's orchestration services that basically combine multiple services, between 2 and 3 kind of complexity, kind of control kind of thing. When you say, okay, I can combine teachers and students to basically retrieve all the students that are learning from particular teachers. That's business logic, right? What that basically means from an abstraction standpoint, just so we stay on point, if my student processing service, for instance, if its only job is to basically offer functionality like give me all the students that have already graduated from college, right? Then this guy becomes your core business logic. And this guy should never, ever, ever be impacted by whether you are using HTTP controllers or gPRC or WCF, or even if you're writing to a file. This guy should never change. What that basically means that this guy should always have local models, local exceptions, local functions, things that you have written by hand. That part is really, really important. But usually your foundation services are split. They're split between two worlds like this. Half of it is still trying to map native models from the broker, and the other half is basically producing local models. And this is the most realistic representation you'll ever see when it comes to true abstraction. Let me do this a little bit nicely. So I'm going to split that guy in half like this. I'm going to increase that, and then I'm going to go here and put that other half in here. So half of this guy is still a layer of abstraction. It knows about native models in your broker. And the other half in this guy is basically going out there and saying, map these native models into the local models and maintain that kind of attitude. So this is going to be student service. See, it's split between two worlds. So what does that mean? Is this really my business logic? Yeah, your true business logic here becomes this little system that I just built in here. This little system becomes particularly this area here, from here to here. That's your area of abstraction. And what that basically means, it means that, when you are presenting this area of abstraction, it means that whatever happens in this layer and so many other layers, like we were going to talk about services in detail, extensively, like these services span out into other services. Like you could have another processing service in here, and you could have another orchestration service in here, and you could have a controller calling your orchestration service. Whatever happens inside that realm should not have any particular native dependency on anything in any way, shape, or form. And this is the topic of this video. We're talking about starting with, now we're inching into building services and building business logic in your ASP.NET, Core API, or your Java or your Scala API, whatever technology you choose to work with. This is what this is going to be focused on. Now, let's just clarify things, so everyone understands. Services can come in all different shapes and forms. Like I just talked earlier, services could have multiple categories. They're not just a service that has business logic. They have particular categories that dictates their responsibilities. It dictates their responsibilities, right? So services themselves fall into one of 3 categories. And bear with me on this one, because this is the big stuff. Any service that you have may fall into one of these big categories. Either they are validation services. So these are services that just validate data and insert data in the database. That's their only responsibility. These are what I call foundation services. That's their main responsibility. And then on top of these validators, right, there are orchestrators. So this the orchestrations kind of thing. And then on top of these orchestrations, there are aggregators, aggregations. So what does that mean? What that basically means, see, you're going to find this tri nature of everything. Like you're going to find 3 and 3s and 3s and 3s and 3s everywhere you go. You're going to find this odd number and 3s and 3s in whatever systems we're trying to develop. What does that really mean? You're going to find some services that under the validations like, foundation services. Under orchestrations, which is your core business logic, you're going to find services like processing services. You're going to find orchestration services. You're going to find services that are coordination services. Look, you're going to find services that are management services. And sometimes Uber management, but we haven't really hit that high yet. I haven't seen that yet. If you have to have an Uber management service, I would be very concerned about your business and how you're breaking apart your stuff, especially in the age of serverless architecture and microservices. I'd really want to understand what you're really combining at this level. What about aggregators? There is one type of these services is what I call aggregation services. An aggregation services basically combine multiple services together just to provide a unified endpoint, where an API can communicate things. And this guy has no rules. It doesn't really do anything other than just offering multiple endpoints across one single point of contact within your system. And we're going to talk about these as well in a little bit. These processing, orchestration, coordination, and management go exactly in that particular order. And all of these have to call some form of validations. And all of these can be called by form of aggregations. So these are the categories, the categorical types of these services, right? You start from a foundation, you're connected to, this is the foundation service. Like on this layer here, this one that looks like the Portuguese flag, this guy here is a foundation service. It's the underlying, layer, the last point of contact, because your abstraction is 1.5 component. Your broker and a half of a foundation service. And this foundation service specifically, its main responsibility to validate all the inputs that are coming in logically, structurally, and dependency. But additionally, their main responsibility is to map any models that are coming from this underlying architecture, SDKs, native components, native UIs, into local models that can be digested by any of these guys. So up until this point here, and up until this point here, none of these services should not, at any point in time, have any form of any way, shape, or form, any form of a non-local model. And when we say non-local model, we talk about models that you have identified yourself. Models that you have actually worked on yourself, models that you have identified yourself, and models that you consider that you have built by your hand. So you own the interpretation of it, you own the implementation of it. So for instance, let me give you an example. Let's say you're pulling in an SDK for SendGrid, right? And SendGrid SDK comes with its own kind of form of, model. So it has a message model and status model and stuff like that. If you let your message model, the SendGrid, let's say you have a broker sitting down here. And this broker in here basically is going and saying, hey, I am wrapping up SendGrid function. So let's say there's a function underneath here that's called send message, and it's taking in a message, a native model message. It becomes the responsibility of this foundation service to take whatever input that's coming from processing or orchestration, and it goes and says, hey, at this point in time here, I need to map a local model, to or from, that message. Your processing orchestration service or orchestration service should never at any point in time be able to know about your native message model. Same thing happens with queues, same thing happens with any other external dependency that you can think of. There are exceptions to some native, business models, like using task and value task and string and all that. That's just the framework that's running everything. But other than that, any other external implementation shall not have access to this kind of layer, because that's where your business logic live. What that basically means, if I go back to the original picture here, your system here should be able to withstand any change whatsoever in technologies or patterns or implementation, because you still have your components that you can literally in some cases, you can actually pick up C# code, literally C# code, and map it into Java code, or Scala code, or Python code, without having to worry too much about the underlying dependency implementations, because what's really happening is that most of the logic that you've written by hand. So you know every single aspect of it. So you won't have to kind of, bend your brain backwards thinking about, how am I gonna map an entity framework function or an entity framework component, into Scala or into Java or into Python or Clojure. How is that going to work, right? But your logic here, let's just assume your logic says if true, whatever the language is, this is why I'm keeping it really COBOL level, if true, right, then return 1 and then else return 0, like this. This logic, you can literally pick it up and put it anywhere, and it will work just fine. Even with contracts and dependencies, like you could also go back here and say, if true, then go ahead in here and call something like storage_broker.insert, and that storage_broker.insert that you're calling in here, and that storage_broker.modify that you're calling in here, storage_broker.update, for instance, that you're calling in here, is abstract. It's just a contract that you can implement in any programming language in the world. That's the beauty of software. That's the beauty of this system, is that you need to focus your energy more on the category of the service that you're building and the level that you're working with. Now, what does that really mean in the real world? This talk is cheap. Linus Torvalds always says, talk is cheap. Show me the code. Show me the code. So let me show you a real world example of building. Let's just start with the types and categories of these services. So if I go down here into this layer, we already talked a little bit about brokers. Let's talk about foundation services. And like I said before, foundation services, I'm going to mark these as empty because I haven't really talked about them yet, not extensively. But let's just talk about foundation services for a second. Any foundation service in the world, just like any service in the world, also does 3 things. Any service in the world will do one of 3 things, or some of them combined, at least one of them. Remember that tri-nature of anything that I talked about in here? Let me show you what every service, like the anatomy of an actual service underneath, what does that look like? Your service will do validations. When you're receiving an input, you'll do validation. And then you will do some processing, which is basically the actual work that you're doing. And then at the end, it may or may not, call or integrate with a dependency. All right, so every service, no matter what it is, will do at least one of these 3, if not all of them. Foundation services definitely do all of them combined. For instance, if you're building a student service, right? Let's take a look at this code real quick. So this is Tarafu, which is an open source social media platform built to deproductize humanity and build a proper social media platform. If you look at this guy in here, this is my service in here. What does this service really do? All it does is that it goes and calls a broker. This is your dependency injection, and it goes and says, I want to call this broker. So this is the dependency piece of this story. But if you are receiving, let's look at another project. If you are receiving let's take a look at this project here. If you are receiving an input, so let's pick up like an input here, like a student service or something. A student service in here. It doesn't matter whether it's here's a student service. Check this out. So there's the validation aspect of a student service. And then there is the integration aspect of a student service. Some people might say processing is a combination of both. And some people might say processing is handling the exceptions that may occur out of these. It doesn't matter what processing is. It could be validating and checking, will the student, we need to modify the student. We need to map. That's part of it. We need to map that student model to something else. Whatever the case may be, you're handling things. So this is a dependency piece. And this guy here is the validation piece. Let me show you an example of all three of them. Check out this service in here. This service here does three things. It does validations, and then it does some processing. It maps a view model into a native model, and then it does a dependency. Every single service you will run into will do at least one or two of these. I would be surprised if you have a service, like there are services that don't have input parameters. So there is no validation needed, and they don't really have any processing, so you just go and call dependencies. So let's go back to our service. Remember how we said services are three categories, and this is the category for each and every one of them. That solar system kind of pattern, the tri-nature of everything, you know? You have stars and planets and moons. That builds your solar system. But also at the lowest level, in your atom level, you have protons, neutrons, and electrons. What is this tri-nature pattern? You'll find it in everything around you, and it applies to software as much as it applies to everything. In fact, object-oriented programming was nothing but an imitation of reality. So every service does validations, processing, and dependency. And even within these patterns, there's also, if you put on the microscope a little bit, there is even more to it. So the validation itself breaks itself into three different patterns. So 3 under 3 under 3. So when you go and say validation, there's three different types of validations. What are these types of validations? There is structural validation. There is logical validations. And there is dependency validation. What's an example? Structural, for instance, validation. See, so this one part, and it also breaks. It's like we're using a microscope and looking deeply into the categories of everything around us in the world, and we're trying to break our software accordingly. So check this out. Any service does validation. This validation can be structural, meaning a string cannot be empty or null or white space. Structural. It doesn't really care about anything related to another entity or another logic. It's just going and saying this is a structural validation. I just want to make sure that structurally this attribute is in good state. There's logical validations, like you saying a student needs to be registered in the school. Their age cannot be more than 10 years old. That's logical validations. You know logical validations when you're comparing an attribute to something else. It could be a constant, it could be another attribute. You're making comparisons against two different constants, or against a constant or against another attribute or variable. For instance, when you go and say, you know, updated by and created by, on create cannot be the same. Or created date and updated date have to be the same. Or created date and updated date has to be the same. This is logical validations. Just an example. And then there's dependency validations, which is a validation that comes in when you can't really tell if something is valid or not until you go hit an external endpoint. What's an example of that? You're going and saying, okay, I have a UI or an API, and this API needs to ensure that a particular student, you know, exists in our system before we move forward by, you know, giving them an exam, right? So you said, okay, we need to give an exam to Michael, for instance. Well, Michael cannot have an exam if Michael doesn't exist in the database. So your foundation service will go and say, does Michael exist in the system? That's a dependency validation, external validation, right? Let's call it an external validation, external or a dependency validation that goes and says, give me data from the outside world so I can validate that request. See how everything is breaking into threes like that, right? And we will talk a little bit more about processing. Like there's mapping and there is, you know, in the processing you have the selection, you have the iteration, and you have the sequential kind of logic. We'll talk about all of that. The same thing happens with dependencies, right? You have owned dependency, you have non-owned dependencies that you can control and talk to, and you have hybrid dependencies, right? Dependencies that's a part of it that's owned by you and some of it that is not owned by you. I can go into the threes for hours and hours and hours. You know, I'm trying to just keep you focused in here on just an overview of what these services are, right? This is what this video is about, is to just show you what these services are. So think about it this way. When you're structuring a truly enterprise level maintainable, componentized, modularized, pluggable and reliable and sustainable system, right? You have to think very long and hard about what kind of models are you leaking into your system. Your gateway, your gatekeeper between these native models and the rest of your software is foundation services. That's what I call foundation services. In the next video, we're going to dive really deeper into foundation services, true implementation, test-driven development, and basically show you how we map and handle the exceptions so these foundation services can open up the door for some processing, high-level processing services, to actually take on that. The good news is that this video might be really, really soon, because what's going to happen here is that if you go on GitHub, you will notice that just right about this time, which is a great time. See, I'm gonna pick examples from the real world. I'm just gonna show it to you. We are doing something called student registration flow. Check this out. We're gonna be talking about foundation services and maybe orchestration services. Maybe we'll tap into processing services as needed. But this flow here is basically saying I want to register a student. So I want to make sure that, I want the student to have a user. So I'm registering a student, a new student in the system. So I'm creating this student component. I'm creating a user for that student. But at the same time, I want to go and say, create a student, registration component, a student registration service, and I create registration service. What is all that? What is all these components? What is these combinations really mean? This guy is basically a composite key, kind of foreign key, two foreign keys combined together to create a composite primary key that basically makes sure it creates the glue between a student entity and the registration entity. And in the process, we're creating a user on the system for that student so they can log in and use the system and check their status and all that kind of bells and whistles. All of that good stuff you will see in here as part of our implementation in the real world problems. The OSSS project, have gone through multiple iteration building foundation services. Everything that you see in here is basically foundation service. Look at all these services. All of these are foundations. Now is the time to start talking about processing and orchestrations. And in that process, while I'm building foundation service and building orchestration service, I'll be able to show you, from a high level perspective, how you actually build that modular, truly abstract system. So before I leave, I really highly recommend you take a look at the standard, the engineering standard. And in the engineering standard, the pieces that we're talking about in here in this system is basically this area, an introduction to services. We talk a little bit about validation, processing, integration, right? We talked about that piece. And then we talk about all the different kinds of how these orchestration, coordination, management services, and aggregation services work. I forgot to put an aggregation in here, but that's part of it. And then we talk about the types. There's validators and orchestrators and aggregators. And then bunch of rules, do or delegate, what every service does. What is the 2-3 rule? What is a single exposure point? What is the pure model port? Every service for itself. So many different rules that we're going to go through. And this is just the tip of the iceberg. There's so many different things that I haven't had the chance to document yet. But I'm going to put the link in the description of this video to the engineering standard. I want you to go ahead and take a look at it and see how you architect truly modular, truly enterprise applications. The stuff that I'm telling you about today, this engineering standard has helped me build over 32 enterprise level projects that follow some form or another of this engineering standard as we are growing and building systems. At this point in time, as I'm speaking to you right now, there is, at least 4 open source projects that I'm engaged in, and almost the equivalent of that on internal projects and private projects that I'm working on. These standards are not just theories, are not just ideas that I'm throwing out there. It's coming from the heat of the battle. It's coming from the reality. Rubber hits the road. We're building systems for enterprise, handling millions of records, and processing all of these requests and all that kind of stuff. That's the stuff that you can build and trust full well, that you can actually drive a truly enterprise application from the beginning till the end, whether it's a UI component or a mobile application or an API endpoint, without having to worry about about, whether, this pattern is going to work for you or not. You'll see a lot of proposals, online about little teeny tiny pieces of information around particular systems. But this is the whole package for you. This is the entire end-to-end experience. Test-driven, following the best practices and standards, and it continues to evolve. Like the engineering standard in and of itself declares that it's always in draft mode. The standard is not perfect, and it will never be, because we are in a continuous state of learning. This is not a divine book. This is not, a Quran or a Bible. This is an experience that is growing, as people are learning and engineers are learning, and we're trying to draw frameworks that can actually drive, our guidelines, to building systems that hopefully will be able to guide us to solve some existential threats like the survival of the humankind and its evolution. I hope this video was eye-opening to you. I just wanted to give you an overview of what services are. And hopefully, you'll find this useful. Please feel free to reach out if you have absolutely any questions, comments, or concerns. I am here for you to answer all your questions. I'm dedicating, the most of my time, the most of my life really, to give you exactly the kind of experience, because maybe you're going to be the next guy that will come up with the next idea that will change our lives forever and help us, solve some of the most complex problems that humanity is facing today. And maybe you'll just take that information and be able to score a job and be able to afford for your family. I am totally okay with that. Follow this engineering standard, ask me any questions, tackle me and put me on my toes, and tell me what exactly are the things that concern you. Try it in your real life projects, smaller projects, home projects or freelance projects or big enterprise projects. I can guarantee you, it'll bring you to a beautiful place where you are a successful senior software engineer that can actually develop products for large or mid or small scale applications. I tell you about this because I've already been there, and it's always beautiful on that other side. Thank you so much for watching. If you have any questions, comments, or concerns, please feel free to drop a comment in the comment section. I am very happy to be able to share that information with you, and I'm very happy to hear your feedback. And don't forget to like and subscribe. Thank you so much for watching. I'll see you in another video.